Assalamu alaikum, dear students. My name is Mr. Uriya Jalil and I'm a physics teacher. After seeing the success of the previous video lessons, I've decided to make them once again. Along the way, you might need some of the concepts you've learned in grade 10 and 11, but don't worry, I'll explain them whenever necessary. But there is one thing I would like to point out before I begin, and that is, at no circumstances, you cannot use these videos as an excuse not to listen to your school teacher. So you can use these videos, an extra support, you can say, or an extra guide, just to help you go through grade 12 physics. Now, if you agree, let's begin. In grade 12 physics, clearly we have 9 chapters. And of course, we'll explain each chapter at a time. The first thing that we have, it is about rotational motion and the law of gravity. What are we going to learn in this chapter? We're going to learn about measuring rotational motion. And after that, we're going to learn about tangential and centripetal acceleration. We'll talk about the causes of circular motion too. Now, the first thing that we have is measuring rotational motion. Now, before starting with this, I would like to tell you a little bit about the types of motion that we're concerned this year, or the ones that we're going to study this year here. The first thing that we have, I would like to tell you about the types of motion. Of course, there are different types of motion here, okay, but we're interested, or we're going to talk about 2 types, the ones that we're going to use them here. Of course, like I said, there are different types of motion, but we only focus on 2. And that is, the first one that we're going to focus is translational motion. Translational motion, okay? And then the other one, translational, the other one is rotational motion here. Rotational motion here. Okay, now what is the difference between the 2? Now, whenever you see the word, or whenever we have translational motion, that means there is a change in position. There is what? There is a change, we can say, in position. Okay, and then when we talk about rotational motion, we can say there is no change in position. There is no change in position, you can say, or location, position. Okay, now we know that motion can be divided in 2. Like, there are, of course, more types, but the first one that we're going to study is translational. There's a change in location or position here. While the rotation, there is no change in position. Let me give you like more explanation regarding this. And of course, this translational would divide to 2, you can say, subdivisions or categories here. The first one we can say linear motion. And then the other one is circular motion here. Circular motion. Now, what is linear? That is pretty obvious. When objects move in a straight line, we call them linear motion here. So for example, let's say an object goes from point A to point B in a straight line. Like, could it be a person walking, could be a bicyclist, let's say, riding a bicycle in a straight line. Or another easy example is a train moving in a straight line, let's say. And the reason why we call it linear, because the motion is in a straight line here. What about circular? I think it is pretty obvious from the name. That is the motion of an object that is moving in a circle. We know that Earth orbits or revolves around the sun, right? So you can see that. How is the path? It is a circular motion. Or it could be any other object that is moving in a circle, and that's it. That is called circular motion. The reason why we call these translational, because when objects go from one point to another, you can see that they are changing their location, whether if it is linear or or circular motion here. So even for circular, we know that at some point Earth is here, at some other points which is going to be another season, let's say, or a different season, it is going to change its location. So the point is, it is going to change its location here. But what about rotation? We said there is no change in position here or location here. So what exactly happens here? Consider having a Ferris wheel here. Let's say this is the axis of rotation here, and now these are the seats of a Ferris wheel, let's say. You can see that when this Ferris wheel is rotating, the only thing that spins is clearly the wheel here. But does the Ferris wheel change its location? The answer is no. So this would be the main difference between rotational and translational. In rotational, the object is just rotating, or you can say spinning, without changing their location, and that is what we can say rotational motion. There are more examples, of course. You can say the Earth or the motion of the Earth while moving, or let's say not moving, rotating on it as orbit here, or spinning on it as their let's say axis of rotation. That is more proper to say. We know that Earth has two types of motion, let's say, and that is rotation, where it is just spinning on its axis, and there is circular motion, where the Earth moves in a circle, and that would be revolution, you can call it, or just orbiting around the sun. Of course, there are more examples here. Let's say another example is this, let's say this fan that is attached to the ceiling here. Now you can see that the blades of the fan are rotating here, are spinning, but does the fan change its location? The answer is no. So these are some of the examples that we can have for rotational motion here. So now, how do we differentiate between translational and rotation? And rotational, we said in translational, the object must change location, while in rotational, there is no change in location. Now, later on, of course, we're going to define each one of them, but there's one thing I would like to tell you before we go to the definition here. Let's say this is the Ferris wheel again, okay, and this is the center or the axis of rotation of a Ferris wheel here. Now, we said these are the seats here. Now, what about if I take the motion of one seat in here? Let's say this is one of the seats that we have, and there is a person in here, okay, sitting there. If we analyze, or if we observe the motion of one single seat, or it could be a point here, you could say, because this is the Ferris wheel here. If you look at the motion of one seat here, you would see that this seat, it is moving in a circle, let's say, or around this axis of rotation. So what that would be here, can I say the motion of this seat, because it is moving in a circle, would that be circular motion? So if I take the motion of one seat here, of course, the motion of one seat, it is going to be a circular motion. Why is it circular motion? Because it is going to move in a circle around the center or the axis of rotation of this Ferris wheel. But if I take the Ferris wheel as a whole, remember, so that'll be the wheel, the base, the axis, and everything together. Does the Ferris wheel change its location? The answer is no. So the Ferris wheel as a whole, it is rotational motion, because it is not going to change its position or location. But if you take the motion of one seat, or it could be a point on this Ferris wheel, or it could be a line on the Ferris wheel, if you take the motion of a point or a seat or a line on this Ferris wheel, of course it is going to be circular motion. That is a very good thing so far. Now let's summarize what we have learned so far. We said motion, there are two types. Of course there are more, but we're only interested in two parts at this point here. We have translational motion, where objects change their location, and then we have rotational motion, where objects do not change their location. In translational, it divides to two categories. Let's say that is linear, where objects move in a straight line, and we have circular motion, where objects move in a circle, and we gave examples too. But for rotational object, we said, or motion, objects do not change their location, but they just rotate or spin, like the motion of the Ferris wheel, or the rotation of the Earth on its axis, or it could be the fan that is attached to the ceiling and it is rotating, or it could be any other thing that you can think of course. And let's not forget this. We said whenever we have rotational motion, if we take the motion of, let's say, one point or one seat, as if, for example, as on the Ferris wheel, if you take one seat, you will see that the seat would be moving in a circle, So based on this, we can generalize something here. We can say in every rotational motion, there is always a circular motion. Just like, for example, now this Ferris wheel, or the Ferris wheel as a whole, it is rotational motion. But if I take the motion of one seat, it is going to be circular motion. So based on this, we can say whenever there is a rotational motion, there will always be circular motion too. If that is true, of course, which is, then we can say circular motion is a special case in rotational motion. But can we say the otherwise? Can we say in every circular motion there is rotational motion too? The answer is no, not necessarily, all right? But we can, of course, definitely say in every rotational motion there is a circular motion here. Okay, so based on that, how can we define a rotational motion and circular motion? Now, rotational, remember, when it comes to definition, first try to memorize the keywords, and then, of course, that makes it a lot easier to memorize or even remember the definition later. So how can we define a rotational motion? We can say rotational motion is the motion of a body or an object that spins around an axis. So remember, rotational motion, there must be spinning. Okay, how about circular motion? We can say that is the motion of an object on a circular path. As simple as that. So the rest, of course, is going to be an extra, because since it's going to be multiple choice, of course, remembering them would be way easier here. So let's go through this one. It says when an object spins, it is said to go under rotational motion, like the, for example, spinning of a Ferris wheel, or it could be the spinning of Earth on its axis. So once again, how do we define rotational motion? It is the motion of a body that spins. So remember, the key word is spinning about an axis here. And then we said for circular motion, it is the movement or the motion of an object in a circular path. And of course, that is the key word for circular motion. And of course, the circular path must be around a fixed point or axis. And we've also learned that if we take the motion of one seat on a Ferris wheel, we said that the Ferris wheel as a whole, is it changing location? The answer is no. Well done. So it is rotational motion. But if we take the motion of one seat, could be one point, could be even one line here. Once this seat is moving, you can see that it is moving in a circle around this axis of rotation here. So the motion of this seat here can be called circular motion. Why? Because it is changing its location while it is moving around this axis of rotation here. Or it could be this bicycle wheel. You see sometimes, like let's say children, let's say, or whoever is riding the bicycle, let's say, sometimes they'll add some reflectors here. So once this tire is rotating here, this reflector is moving in a circle, as you can see here. So we can say the motion of the reflector, or it could be a point mass, or it could be a piece of mud that sticks to the tire, because it will be moving in a circle. So their motion is circular motion. But if we take the tire of the bicycle as a whole, then that'll be just spinning without changing its location, because you can see that it is upside down. So that is rotational motion. But the motion of a reflector or a piece of mud, or it could be any point on this bicycle, or bicycle wheel, it will be moving in a circle. Now that is clearly all about this. Let me show you one more thing, this PowerPoint presentation, and after that we'll proceed here. This might also help you remember what you've studied so far. The first thing that we said there are two types of motion. There is translational and rotational. We said for translational we have two types, of course. We have linear motion, and then we have circular motion. In linear motion, objects move in a straight line like this, bicycle is moving, or the motion of this train. While for circular motion, objects move in a circle. The reason why we call these translational, because they are changing their location while they are moving here. But on the other side here, we have rotational motion. We said objects do not change their location here or position, like the motion of this bicycle wheel, or the motion of this Ferris wheel here, or it could be the motion of the Earth orbit, let's say, rotating on its axis here. But remember, if you take the motion of any seat, let's say here, you can see that this seat would be moving in a circle around this center point here. So we can say the motion of one seat, it is going to be circular. This is why we say circular motion is a special case in rotational motion here. All right, now going back to this. So now we've learned about circular motion and rotational motion, right? Okay, so if we take the motion of any point, that'll be circular motion if it is on a rotating object here. Examples of objects moving in a circle, like this satellite, it is, let's say, orbiting the Earth, so it is a circular when you attach a mass to a string and then you move that in a circle in the air, that is circular motion here. And of course, there could be a car, let's say, moving on a racetrack, or a race car moving on a racetrack. So anything that moves in a circle or circular path around a fixed axis, we can say that is circular motion here. Now, based on what we've learned, we can conclude these study tips here. We can say when an object is rotating, the motion of any point on that rotating object, it will have what? Around an axis, will undergo what? Will undergo circular motion. So based on this, we can say circular motion is a special type or case. We can say circular motion, it is a special case or type of a special case in rotational motion. Let me not forget, okay? So again, circular motion is a special case in rotational motion. In other words, we can say in every rotational motion, there will always be circular motion here. And the third point, rotational motion include all kind of motion that involves objects, let's say turning or spinning around some axis or center point. Now at this point, of course, we have a very important question. How do we measure the distance traveled by an object that is moving on a circular path, right? If you remember, in grade 11, of course, when an object was moving, in grade 11, let's say when an object was moving from point A to point B here, it was traveling a certain displacement over a certain time, and we used to find velocity and say, velocity it is equal to delta x over delta t, and it was measured in meter per second. And how did we measure the displacement? Of course, we could have used a ruler, could have used a, let's say, meter ruler, or it could be, let's say, a measuring tape here. But do we or can we do the same thing when it comes to circular motion? The answer is no. And why can't we do that? That is because when an object is moving in a circle, you can see that the direction of the motion is constantly changing. What does that exactly mean here? So let's say we have an object that is moving. At this point, the direction is in this way. At this point, the direction is in this way. At this point, the direction is in this way here. So we cannot just, like put a ruler or a meter ruler, let's say here, and just measure how far the object traveled. We cannot do that because the direction of the motion is changing. So what do we do instead, or how do we do the measurements? We'll measure the angle that is covered by the object. And how do we do that? Well, if this is the center of the circle here, or you can say the axis of rotation, of course, we know that the distance from the center to the edge of a circle, we call it radius. Okay, and of course, we'll use the letter R to represent the radius here. Okay, and then if an object is going from, let's say, this point here, let's just call it point A. Let's erase this one. Okay, it is going from point A to point B, or it could even go to point C here. So once it goes from point A to point B here, it is going to cover some angles here. What about when it goes from point A to point C? Of course, now it is going to cover another angle. Clearly, this angle is going to be bigger than the other one. But once again, how do we do that? Okay, so this angle is the one that we're going to measure here. But how do we do that exactly? We'll say, let's bring one more circle here. Say if an object is moving in a circle, one more time, this is the axis of rotation, you can say. That is the radius. Let's just write R here. And then if the object goes from point A to point B here, that is, of course, this length or distance that is traveled by the object, it is called arc length here. What is it called? Arc length. And of course, we use the letter S for that. S clearly represents the arc length here. And this is the radius, you know that what it is. So this angle that is, or we're trying to find this angle that is covered by the object. So how do we find the angle that is covered by the object here? We'll say theta, just move this one up. We'll say theta here, that is the angle covered by the object. It is equal to arc length divided by what? Divided by the radius here. Now let's just use, let's say, symbols here. Arc length, we'll use letter S, and then the radius, we'll just use the R for that. Now let me give you an example. This is how basically the angle is measured. Let me give you some numbers and see how it is done. Let's say when an object is going from point A to point B, it is going to travel a distance of, let's just say, 30 meters. That's all right, let's just say 15. Let's just lower the numbers here. 15 meters. Okay? 15 meters, let's say. And the radius of this circle, let's just say it is 30 meters here. So how do you find this angle that is covered or swiped by the object here? Or swept, you can say. So in this case, of course, we can say arc theta, arc length divided by the radius, and that is letter S divided by the R. Let me just erase this one and write the numbers here. So at this point, we can say the arc length that is covered by the object, it is 15 meters, and then the radius of the circle is 30 meters here. So clearly, meter and meter cancel out. 15 divided by 30, that is going to be equal, or it is equal to 0.5. But 0.5 what? Now there's no unit left, of course, to mention here. So, but how do we separate this 0.5? Let's say, what is this exactly 0.5? Is it 0.5 second, meter, kilometers? Let's say, what is it exactly? In order to differentiate this 0.5 from other things, of course, now we'll have to use something to describe. And now we're going to use a unit here. It is called the radian. So radian, it is the angle, or it's the unit that is used to describe the angle theta that is covered by the object here. Later on, we're just going to use RAD for short. We'll just call it, we're still, like pronounced as radian here still. So now what is radian exactly? It is a unit used to describe the angle theta that is covered by an object here. But remember, radian is dimensionless. And what do I mean by that? Let me give you an example. Now we know that meter is a unit for what? Is a unit for length. What about kilogram? It is a unit for mass. Well done. What about second? It is a unit for what? It is a unit for time. Well done. What about radian now? You see, it comes from nowhere. This is why we call it dimensionless. In other words, those things that we measure, these are called dimensions in physics. Okay? Now, these are dimensions and these are the units here. Okay? But now, where does the radian come from? Of course, it comes from nothing. So we'll say no dimension here. Okay? That is a pure number with no dimension, you can say. So let's go through this one more time. Because the unit cancel out, so in order to separate this, in order to know what is 0.5 exactly, we'll have to use a unit to describe this angle theta. So we will use radian here. Now that was a very good example, but let me give you one more example here. Let's just say, like, what will happen if an object, again, it is going to move in a circle, but this time, what happens if the arc length, which is 15 meters, that is equal to the radius? What if the radius is also 15 meters here? What would happen this time? So once again, theta, it is equal to arc length, okay, divided by what? Arc length divided by the radius here, or let's just use the symbol here. Letter S, that'll be the arc length divided by the radius. And one more time here, theta, it is equal to the arc length is 15 meters. The radius is also 15 meters now. So these two cancel out, of course. Now 15 divided by 15, that'll be 1. 1 what? 1 radian here. Now, of course, we can use this as a definition of radian. What is exactly 1 radian, or how can you define 1 radian? Now, but we can get 1 radian if the arc length, as you saw, if the arc length it is equal to the radius, then this angle that we get, it is equal to just 1 what? 1 radian, and that's it. So if I ever ask you what is 1 radian, you'll say it is the value or the magnitude of an angle, or it is an angle. But when do we get that angle? When the arc length it is equal to the radius. Well done. Now later on, of course, we're going to convert like these delta theta in different, let's say, formats here. So this is radian, which is approximately equal to 57.3 degrees. And then that is also equal to about 0.16 revolutions as well. You might not know what are these here, but I'll explain them later. For now, just remember 1 radian, it is equal to or approximately equal to 57.3 degrees, which is equal to 0.16 revolutions here. Okay, now next, what happens, let's say, or this angle, since I've just mentioned that, it can be measured in 3 different methods here. What do I mean by this? This angle can be measured in radian. This angle can also be measured in degrees, let's say, can also be measured in revs as well, or revolution, let's say. But later on, we're just going to call it a rev for short. What exactly do I mean by this here? Okay, now imagine or consider, let's say, we have an object that is moving in a circle. If this object that is moving in a circle, let's just say, here's a circle. Now we have an object, this is the center, the axis of the circle here, and then here is an object at point A. It is going to move around the circle, let's say 1 full turn, or you can say 1 full cycle, 1 full revolution, let's say. So if it is 1 full revolution, what is the angle that is covered by the object here? Just write this one nicer, maybe a little bit. So 1 full circle here. So if that is the case, what is the angle that is covered by the object here? Well, you do know that the distance traveled around a circle, hopefully you studied that in math, it is called circumference here. What is it called? Circumference. So circumference, it is represented by letter S, or C, my bad. It is equal to what? It is equal to 2 pi r. What is exactly this? This is the distance traveled around the object here. So can I also say this is the arc length? So we can say the arc length, or let's just call it del S here, that is the distance traveled around a circle, which is equal to the circumference, and circumference that is equal to 2 pi r. But if I want to find the theta here, the angle that is covered by the object, we'll say it is equal to the arc length divided by the radius, yes? But what is the arc length here? It is equal to the circumference, and that is equal to 2 pi r in here. And then divided by the radius, yes? No matter what the radius is, this 2 will cancel out. So what is the angle theta now? We can say the angle theta, it is equal to 2 pi, but 2 pi what? 2 pi radian. So based on this, we can say when an object is traveling around a circle here, the distance traveled, it is equal to the circumference, which is equal to 2 pi r, that is the arc length. And if we want to find the angle, then we can say that is equal to 2 pi radian. But remember this, if an object is traveling around a circle, like 1 full circle, didn't we say that is 1 revolution? Yes. So based on this, we can say when an object is like let's say making 1 full revolution, that is equal to 2 pi radian. And of course, if we use angles, let's say, or if I use the other angle here, we know that this is 90, yes? Let's just perhaps clean this a little bit so you know what I'm talking about. So let's say this is the center here. You know that this is 90, that is 180, that is 270, this is 360. So when an object is making 1 full circle in degrees, that is equal to 360 degrees as well. Okay, remember this. Now we're going to use this as a key conversion of delta theta, or the angles, from one form to another. But remember this, let's summarize what we have learned so far. We said that when an object, or how do we measure the distance traveled, let's say distance traveled for an object that is moving in a circle. We said because the direction of the motion is constantly changing, we cannot just measure displacement, or the, let's say the displacement the way that we used to in grade 11. So what do we do instead? We'll measure the angle that is covered by the object when it is moving in a circle. And how do we do that? We'll say the angle, theta, that is the Greek letter, of course, for that. It is equal to the arc length, the distance traveled on the edge or the rim of a circle, divided by the radius of that circle. And we also said that if the arc length is equal to the radius, then the angle that we get, it is going to be 1. But 1 what? We said 1 radian. So we'll use the unit radian to describe the angle that is covered here. And we also define the radian to said 1 radian. It is an angle whose arc length it is equal to the radius, which is approximately, it is equal to, do you remember the number? It's 57.3 degrees. And also equal, you can say that is equivalent to 0.16 revolution. And now that is what we have. We said that angles can be measured in 3 different ways. Okay, it can be measured in revolutions. For example, if an object is moving in a circle, let's say it might move in a circle like once, that'll be 1 rev, or 2 times, that is 2 rev. If it is 3 times, 3 rev, or it could be, for example, measured in pi radian. So let's say half a circle, that is the whole thing, it is 2 pi, right? So if it is going to start from this point all the way back to this point. But if it is half a circle, that'll be 1 pi, and of course, you can take less than half as well. But if it is in degrees, we know that if it is 1 full circle in degrees, that is going to be 360 degrees. What if it is half a circle? That is obvious, which is 180. If you take a quarter of a circle, that is 90 degrees, and so on and on. Okay, now the next thing that we need to know is how we can convert the angles from one form to another. What do I mean by this? But before we do that, remember this. We said 1 rev, that is equal to 2 pi radian, which is equal to 360 degrees. Now, I need you to remember this because we're going to need this here in order to convert the angles from one form to another. So let's start with this one here. Start something easy, let's say. Let's say we are going to convert 2 rev. How about, yes, let's just say 2 rev to radian here. Okay, now how are we going to do this? If you follow what I say, like carefully, you will learn how to do this very easily, of course, without making any mistakes at all. So let's go ahead and try this. So first of all, the first thing you need to do is write what is given exactly the same. Just copy paste what is given here. So can I say 2 rev here? That is 2 revs, which is given. And then we'll say multiply by a conversion factor. I'm trying to convert rev to radian, so I'll have to write rev below or the denominator and radian up or numerator. Why do I need to do this? So that I can cancel out rev with rev. But before we do this, there's one thing I would like to do first. Now, this is called a conversion factor. Now, after you wrote this one, you need this key conversion again. So we can say, now the next thing is write the numbers beside each one of those that you wrote here. Beside radian, it is written 2 pi. Beside rev, there is just 1 here. So now we can cancel out rev with rev, and then now all we have to do just 2 times 2 pi divided by 1, that is equal to 4 pi radian. That is this simple here. Nothing else. Can I do the reverse? Can I convert, let's say, radian to revs? Absolutely, yes. So let's do that in the second case. Let's say I have, let's just say 3 pi's, okay? Radian, convert this one to revs. How can I do this? We said the first thing that you need to do is write what is given the same. What is given here? 3 pi radian. So let's just write it down. 3 pi radian. That is all what you need to do. Now multiply by a conversion factor. We're trying to convert radian to revs, yes? So radian below, revs up. Again, why do I need to do this? So that I can cancel out radian with radian. Now the next thing is, look at the key, let's say, conversion. What are the number that is written beside each? Beside rev, it is 1, written here. Beside radian, it is written 2 pi. So just write 2 pi in here. Once again, if you didn't cancel them out yet, you can cancel them out now. So pi and pi cancels out. It is going to be 3 times 1, that is 3 divided by 2. That is going to be 1.5. What is left now? Rev here. And that is how you can simply convert from one form to another. That is, if we want to convert rev to radian or radian to rev, yes? Can we convert, let's say, radian to degrees or degrees to radian? Yes, it is exactly the same thing here. So let's use this one here. Okay. All right, so the next thing is you can start practicing by let's say using any numbers that you want. As long as you're using the same method, it is 100% accurate, and hopefully you will never make any mistakes. Now let's say second conversion that we're going to do is we're going to convert, let's just say 1.5 pi. We're going to convert this to, let's say, degrees in here. Okay, how about we use something simple first? Let's say 2 pi first. Convert this one, 2 pi radian, convert to degrees here, to avoid using the calculator at this point. Okay, so what is the method that we've learned? First, we said write what is given the same here. So now here's what we're going to write. 2 pi radian. So far, I haven't done anything. I just wrote what is given exactly the same. Now I'm going to use a conversion factor. We're going to convert radian to degrees. So I'll write radian below and then degrees up here. So what are the number written beside each one of those? Degrees, it is 360. And then radian, it is 2 pi in here. So once again, radian and radian cancels out. And then we can say 2 pi and 2 pi cancels out. And then that is 360. This is 360 degrees, and that's simple. And of course, you can use any other numbers. It could be 1 pi, it could be 1.5 pi, it could be 1.2. It doesn't matter. It could be any number at all. Okay, and then there is, how about if we do the reverse? Let's say convert 180 degrees, let's say, into radian here. So how do we do this? We said write what is given the same. So this is what we're going to do. 180 degrees multiplied by a conversion factor. Right? Degrees below. Why? So that I can cancel them out. Convert degrees to what? Convert degrees to radian. So write radian up here. Okay, so what are the number written beside each one of those? For radian, it is 2 pi. For degrees, it is 360 degrees. The degrees cancel out with degrees, of course, you agree with me. And then we can say divide by 180, that is 1. Divide by 180, that is going to be what? 2. Very good. Now this 2 and 2 cancels out. So what are we left with here? We can just say it is equal to pi radian here. So now this is how easy it is. Converting 180 degrees to radian, it is simply equal to pi radian. That's it, Yani. Now, if you remember previously, we said that. So I'll erase this one, but before I do, remember this key conversion here. Do you remember we said 1 radian? It is approximately equal to 57.3 degrees. Let's find out if this is true, okay? So simply, we can just say 1 radian. Use a conversion factor. Remember, we're trying to convert radian to degrees. So radian below, degrees up, right? So do you remember the numbers in the key conversion? The degrees, it was 360. The radian was 2 pi. So radian and radian cancels out. So it is 1 times 360, and then divide by 2 pi. And of course, you get approximately about 57.3 degrees in here. And that is that simple, all right? You could do the reverse as well if you want to. How about if we convert, let's say, what is 1 radian in revolution here? We could do the same thing. We can say 1 radian. How can we convert this into, let's say, revs? Radian below, revs up, right? Do you remember the numbers? It was 1 beside the rev. For radian, it was 2 pi. So radian and radian cancel out. 1 times 1, that is 1, divided by 2 pi. It is going to be, where you can say it is about 0.16 revolutions here. So this is where, of course, this number comes from. We can say 1 radian, that is equal to, or about 57.3 degrees, which is about 0.16 revs in here. Right? Remember how we can do that. Now let me give you a question to work for yourself here. That'll be your homework, and it's one of the WYSITY questions as well. Can you convert 1 degrees into radian? And that is 1. So now you can convert this 1 degree to revs as well. See how you can, or what are the numbers that you get there. Okay, so you see, that is pretty simple. I believe there is one more conversion left. Like if you want to convert, let's say that would be the third one, converting rev 2 degrees and vice versa, let's say. Let's say I'll use 0.5, let's just say 0.5 revs 2 degrees here. Okay, so remember, rev below, degrees up, right? That's this. And then remember the numbers. Beside degrees, it was 360. Beside rev, it was just 1. So these 2 will cancel out here. 0.5 times 360, that equals to 180 degrees. And that is as simple as this. Okay? Now you can write degrees like this, or you could just write 180 with this, let's say, small circle here. But for now, so that you can see like the name clearly, we'll just write it in this format. Maybe later we'll just write this way. Okay, what if we do the reverse? Let's say convert 90 degrees into revs, let's say. By the way, you might have noticed I might use 90, 180, 270, or 360 so that I avoid using calculator. But we can, of course, we can use any other numbers that we have. It works the same way. So how do we do this? Write what is given the same, that is 90 degrees, multiply by degrees below, right? But why? Because we want to cancel that out. Excellent. Rev above, very good. So do you remember the numbers? 1 rev, that is equal to, or divide by 360 here. So degrees and degrees cancel out. By 90, that is going to be 1. By 90, that is going to be 4, yes? Okay, so 1 divided by 4, that is equal to, you can say 1 over 4 of a rev, that is one way, and that is, of course, equal to 0.25 of a rev as well. So these are both correct. Like, which one do you have to use? Of course, the option of the WYSITY question would determine. If you had, if you see 1 over 4 rev, you can choose this. If you didn't see this, see if there is 0.25 of a rev. And that is as simple as this, but there's nothing more than that. After you get used to this one, like you practice this, you master this method, then of course there is another way, which is a bit easier. I mean, maybe a bit faster too, but first I need you to get used to this very well, master how you can convert from one way, from one form to another. Then of course I'll tell you the other method. All right, now let's get back to the pamphlet or the Malzama and see what is left, or if there is anything we didn't cover. All right, so we said, how do we measure the distance traveled by an object in a circular path? Well, we measure the angle, all right, that the object is covering while it is moving in a circular path. Why do we use the angle? Because the direction of the motion continuously is changing. So how do we do that? We'll say the angle theta, it is equal to the arc length, which is represented by letter S, divided by the radius, and that is the radius. When a circular motion is measured in radians, why is that? Because these are both measured in meter and meter, they both cancel out. So we also said that when the arc length S, it is equal to the length of, or the radius, let's say, the length of the radius, then the angle that we get, it is going to be 1 radian. If this arc length, if it is equal to the radius, then of course, this angle here would equal to just 1 radian, which is approximately equal to 57.3 degrees, and that is about 0.16. You can add this one here, which is also equal to 0.16 rev as well. Remember, radian is a pure number with no dimensions. We said that angles can be measured in 3 different ways. They can be measured in radian, in degrees, and also in revs as well. So watch this. It says, when an object completes 1 circle, or you can say 1 full rev, you can see that completes 1 circle. That is 1 revolution around an object. Then the arc length, it is going to be Okay, the arc length is going to be equal to the circumference, which is equal to 2 pi r. And how do you find the theta, the angle? We'll say it is arc length divided by the radius, and that is 2 pi r divided by the radius. The radiuses cancel out, so we will be left with 2 pi radian, and that is, of course, when do we get this? When there is one rev, and this in degrees, it is equal to 360 degrees. And of course, we can use this as a conversion or a key conversion from one angle to another. So hereafter, you need this. By the way, you might also use, like if you divide each one of those by 2, what will happen if you divide each one of those by 2? Then, of course, you get pi radian here, and then that is equal to 1 over 2 of a rev, and that is equal to 180. So instead of the key conversion, you can use these numbers here, but there's no difference here. I just recommend using the other one without simplification here. Now, there is this study tip here says doing calculation, which would be most beneficial for later, because we're going to use delta theta in equations. This delta theta must be measured in radian only. So what do we do if it is not in radian? We convert. For example, we might give you theta in degrees, or let's say in revs, but if you're ever going to use that number in calculations, you have to convert from rev or degrees into radian. So only radian is allowed to be used in calculations. Okay, so we've mentioned this one. You can use this, or you can simplify this and use this one here. Now, this is something I would like you to know here. Now, when an object is traveling on or moving in a circle, if it is completing one full circle, that is one rev, in revolution, of course, which is equivalent or equal to 2 pi radian, and that is equal to 360 degrees. What if it is making half a circle? Well, what is half of one rev? That would be 0.5, 1 over 2. Half of 2 pi, that is 1 pi, and half of 360, it is going to be 180. What if it is just a quarter? That is 1 over 4 of a rev, that is pi over 2 radian, and that is 90 degrees, you can say. And if it is 3/4, this would be the numbers. All right, now let's talk about this one a little bit. Now, hopefully you've learned how to convert the angle from one form to another using the method that I just told you. Once you practiced enough, then of course you can, or I can tell you that it is safe enough to use this one too. How can we use this method here? This one is a bit faster, I agree. Okay, even though, like if you don't have time, you can use this. If not, you can always go back and use the other method here. So if we ever going to do this one here, for example, if I want to convert revs to radian, all I have to do, just remember, you could just multiply by 2 pi, because every rev, it is equal to 2 pi radian. So whatever, for example, if it is 1 rev, 1 times 2 pi, 2 rev, 2 times 2 pi, and so let's say, and on and on. So that is how we can convert revs to radian. What if I want to, for example, convert radian to degrees here? Now, all you can do, just multiply by 57.3. And why is that? Because every radian, it is equal to 57.3 degrees here. That is if we want to convert from radian to degrees. And then the third one, if we want to convert revs to degrees here, remember every revolution, it is equal to 360. So you could just multiply by 360 degrees. Now at this point, you might wonder, what if I want to convert radian to revs, Baba? If you remember, or if you know this, then doing the reverse would be very easy here. So if you want to convert radian to rev, instead of multiplying, you'll just divide by 2 pi. And then if you want to convert degrees to radian, you will just divide by 57.3 degrees here. And if you want to convert degrees to rev, you will just divide by 360 degrees. Let me give you 2 examples here. Let's say we're trying to convert, let's say 1.5 rev to pi radian, okay, to radian, let's say, to radian. Now, just all you have to do, this is 1.5, all you have to do is doing this, 1.5, instead of this rev, didn't we say every rev is 2 pi? Just write 2 pi instead of the rev here. So 1.5 times 2 pi, that is going to be what? 3 pi radian, and that's it. What if we want to do the opposite? Let's say I have, I don't know, let's say 5 pi's radian. I want to convert that to revs in here. If you want to convert this to rev, just divide by 2 pi, and that's it. That is going to be, now we could say that 5 pi divided by 2 pi, it is going to be 2.5 rev, and that's it. That's it. Okay, this way, of course, it is easier, but I will recommend you master it the other way first, and then you can use this one too. How about if I want to, let's say, convert radian to degrees here? Let's say converting, I don't know, let's just say pi radian to degrees in here. Now, this is what you need to do. So pi radian. Now, instead of this radian, just multiply by 57.3, because we said every radian, it is equal to what? It is equal to 57.3. Now, this pi, of course, there is one more thing perhaps I didn't mention so far. You can write pi as a pi. If not, you can write pi as 3.14, because it makes no difference whether you write it in this way or you can write digits instead, and then you can just multiply by 57.3. Let's get a calculator and see what is exactly that equal to. Remember, it is pi. All you have to do, just multiply. So we have pi. Of course, you can press shift and this, whatever, depends on your calculator. You can just press that in your calculator, multiply by 57.3. The answer is going to be 180 here. And I think that's simple enough, right? So it is going to be 180 degrees here. Now, how did I mess that though? Okay, but that's easy enough. You can see that. If you want to convert pi radian, that's a bit funny though. If you want to convert pi to degrees, I don't know why am I using even if I'm using calculator, that is 180. That's a bit odd though. Okay, now what if we want to do the reverse of this? That means if I have degrees, I want to convert this to, let's just say I have 270 degrees. I want to convert this to radian. How do I do this, man? We said if we ever want to convert degrees to radian, we'll simply divide by 57.3. So now just divide by 57.3 and see what do you get. 270 divide by 57.3. The answer is going to be 4.71. Let's just, like say 4.7 radian, and that's it. See, that's simple here. Can we do the same thing here? Yes. Okay, let's make this one quick. Let's say we have 2 rev. We want to convert this one to degrees in here. So remember, 2 rev. Every rev is 360. So instead of this, you could just multiply 2 times 360. Correct? That is 720 degrees. That's it. What if I want to do the reverse? Let's say I have, let's just say 360 degrees. That's easy, right? I want to convert this to revs. Remember, 360 degrees, all you have to do, just like if you want to convert degrees to rev, just divide by 360. So once you divide by 360, then you will get 1 rev, and that's the answer to that. I hope you also understood this one as well. It might need some time, perhaps, to get good at this, but of course, don't rush it. If you understood or know how to do the angle conversion using the first method, that is pretty great actually, or amazing. And then for this one, if you're not good at this at a first glance, don't rush it, please. Over time, you'll slowly, you can use this or use this method without making any mistakes. So it's totally fine if this one doesn't seem easy at a first sight. Now we have this, of course, where you can use this one instead. So if we ever want to convert revs to radian, we multiply by 2 pi, radian to degrees multiplied by 57.3 degrees. And if I want to convert revs to degrees right away, then we'll multiply by 360 degrees. And if we want to do the reverse, degrees to radian, divide by 57.3, and then radian to revs, divide by 2 pi, degrees to revolution, divide by 360 degrees, and that'll be pretty easy. Now this one, angle conversion, I told you how you can convert the angles from one, let's say from one form to another. This is basically uses the method that we've learned first time. So give yourself some time and practice those or some of those. But if not, I have some Wizati questions for you to practice them in a bit. So we have a question here says, how many revolution, that is, by the way, whenever you see an orange tag, that is clearly a past Wizati question. Says, the question is, it says, how many revolutions equal to 270 degrees in here? So are they asking us to convert 270 degrees to revs? Yes, so let's try both ways here. So remember, 270 degrees, I'll write degrees in this way, multiply by, use a conversion factor, degrees below, revs up, right? Do you remember the numbers beside each? For rev, it was 1. For degree, it is 360. Now, degrees and degrees cancel out. Then this and this cancel out, you can say. So 27 divided by, or times 1, that is still 27. Or let's just say 270 times 1, no need. Just divide by 360. And then the answer you get it is going to be 0.75. Don't be surprised if 3/4 is given, okay, because this is exactly the same thing. So what is the correct answer here? The correct answer, it is going to be C. Well done. See how easy it could be? Now, how about if I use the second method? Can I do the second method? Yes. How do we convert degrees to revs? Remember? All right, we're going to, if you ever, well, first of all, if you remember, it was this, right? Rev 2 degrees was multiplied by 360. But if you want to do the reverse, you divide by 360 here. So can I just simply divide 270, that is in degrees, by 360? I'll get what? 0.75? Yes, and that is going to be in revs. See, this one is, of course, is a lot easier. But if you're not good at it, don't try it yet. Okay, don't try it yet. Okay, now there is a chapter review question, right? Before doing this question, I would like to make a pass on this, and I would like to solve some of those Wizati questions, and then I'll get back to this. All right, so let's do some of those, and I'll also give you some keys so you can convert angles very easily. Angle conversion, of course, will be in Wizati every single year. It's one way or another. Okay, so it says choose the correct answer, whatever. Every 2 pi radian is equal to. Have you noticed this or not? It says 2 pi radian it is equal to. They don't ask you to convert 2 pi radian into something, but if you noticed, for example, if you have noticed the choices here, you can clearly see that all the choices are in degrees here. Isn't that an indication asking you or telling you to convert radian to degrees? Yes, well done, and that is correct. So let's just see how we can do that. First method, we said 2 pi radian, right, what is given the same, radian below, degrees up. Do you remember this still? So the number beside each one of those for degrees was 360. For radian, it was just 2 pi. So radian and radian cancel out, 2 pi and 2 pi cancel out, and that is what is left now, 360 degrees. Do we have this in the options? Yes, and that is option A. Well done. What about the other method? Can I use the other method too? Absolutely yes. So 2 pi radian. Remember, every radian it is equal to 57.3. 57.3. So just multiply 2 pi by 57.3. You again will get 360 degrees, and that would be option A. I think this one is easy. It says every 1 radian, we've learned that, it is equal to 57.3. Be careful with this. It is not 53. It is 57.3. All right. And questions like this. Look, Baba, if you have questions like this one here, I would recommend you always convert these fractions into, let's say, numbers or digits here. Because like once you press this in your calculator, sometimes it just gives you the digits instead of giving you a fraction. So the best option is to convert those. 3/4, that is, we can say 0.75. Okay, 0.75. 4 over 3, that is 1 point what? That is 1.33, right? There are a bunch of 3, but we'll just write this for now. 1 over 2, that is 0.5. And then 3 over 2, that is 1.5 here. So now once you did this one, by the way, these are pretty simple. It is obvious here. But what if the numbers were something like you didn't know? Then it is always safer to make sure that all the fractions are changed to numbers so that you can easily tell. Now, the next thing, all you have to do is just divide by 270, let's say, or convert 270 degrees to revolutions here. So how do we do that? Using both methods. 270 degrees multiplied by conversion factor, degrees down, revs up. There was 1, there's 360, yes? Degrees and degree cancel out. So 270 times 1 divided by 360. And of course, you'll see that the answer you get it is going to be what? 0.75? Yes, well done. And that is the correct answer here. All right, now moving to the next one here. Okay, there's something else also I would like you to be aware of. Remember, this was one of the homeworks that I just gave you like earlier. But before you do this, make sure you convert this one to a number. What is 3.14 over 180? That is clearly pi over 180, yes? 3.14 or 1/4 divided by 180. The answer is going to be or equal to 0.0174. 0.0174. So what is it exactly? That is the digit. Now you can safely convert 1 degree to radian here. Now, using both methods or whichever the method that you prefer. There's another question here, says 1 over 10 revolution equal to how many degrees? That is easy, I believe. You can do this one. Yeah, I don't do this one here. Okay, now this one is also easy enough. 3.14 over 180 radian, it is equal to this much degree. That is easy enough, they can say. All right, now what about question number 10? There was one more question actually before 10. Let me go back and get back to this one here. That is question 3 here. Okay, now be careful here. A lot of students, especially if they're not good, and if they don't use a calculator, they might get the answer wrong. So, for example, it says 10 pi rev, right? It is equal to which one of those? If you're not certain, do exactly what I told you regarding this. Now, you might see here it's given 20 pi squared. How about you just convert this one or write a number instead of this? Press 20 times pi squared in your calculator, see what is the answer. Then it would be way safer to convert 10 pi rev, let's say, to those. You can see that they don't tell you convert to what, but all the options are in radian here. The reason why I'm telling you this, because it could be a bit tricky. 10 pi revs equals to how many radian? We've learned that every rev, it is equal to 2 pi. So can I just do this here? So now 10 times 2, that is going to be 20. The part that where some students might do wrong here, they might just write pi in here, okay? No, that is incorrect, because 10 times 2, that is 20. This is pi times pi, and of course that is going to be pi squared. But if you're ever going to, for example, plug in these numbers into your calculator, and then if you convert this one to a number, you will never have or face this problem. Hopefully you can get it right always. All right, now the next question that I want to do, or the last WSAT question here, is this one. It says what? A radian, okay? RAD or rad, it is an angle whose arc length it is equal to its radius. Now at this point here, it might be a bit confusing for some of the students, because this is exactly, or maybe they don't know, this is the definition of 1 radian. Do you remember, like we said, what was 1 radian? It is an angle whose arc length it is equal to the radius. So if you've noticed here, it says whose arc length, even if you didn't remember the definition, you can always get back to this. It says whose arc length is in this arc length, that is, let's say the S, okay? It says the arc length, it is equal to what? It is equal to the radius. So if I want to find delta theta or theta, the angle, we said it is equal to arc length divided by the radius. But if the arc length is equal to the radius, can I write the radius instead? Yes. Now these two, of course, will cancel out. So it is just going to be 1. But 1 what? It is going to be 1 radian, even if you didn't know. Now look at the options. Do you have 1 radian? No, of course not, because that is the definition of 1 radian. But just in case, you search or look at the options. Do you have 1 radian? No. But if you've noticed, you have degrees. Isn't that an indication to convert 1 radian to degrees? Yes. So how do we convert radian to degrees? We could simply say, we've learned that every radian it is equal to what? 57.3 degrees. So just multiply. Once you multiply, of course, you get 57.3 degrees. Do we have this in the option? No, but you have something else instead. If you're not careful, you might just go and choose this one. You see, sometimes you see posts maybe on social media or whatever, there are English sentences, let's say, but what they have done is they relocated some of the, let's say, some of the letters in a sentence. But of course, because you've used to this, right, or maybe you're fluent in English, your brain automatically puts all the letters that are misplaced, puts them back to their location, and then now you can easily read the sentence without any mistakes here. So if you're not careful, your brain will put this number, rearrange that automatically, and you will see this number is 57.3, and you might just choose this one, and of course you will end up losing 2 marks here. So make sure, because you're stressed, because you're worried, I don't know, maybe you're under a lot of pressure, so you might not be focused, but always have a sharp focus. Make sure what do you read, what is written here, and then you can clearly tell that this is not the correct answer. If it is not 57, that is also incorrect. So if these two are incorrect, we cannot say all the answers are correct. So now we're left with one option here. Do you remember what I've told you regarding this? Maybe you might say, Mr. This is easy. I agree. Okay, but what if it was not that easy? Then always convert this to a digit in here. So if you convert this one here, let's just do that. That is 1 divided by 2 pi. What exactly equal to? That is 0.159, and that is about, we can say, that's about 0.16 revs here. So now all you have to do is just convert 1 radian to revs here. And how do you do that? Just multiply, or after divide by 2 pi, and then of course you'll get 0.1, approximately 116 rev. You might say, why do I need to do this? Isn't that exactly 1 over 2 pi and what is written here? Yes, maybe it's easy here. You can tell, what if it was a different situation? And you always remember to change this one to a number, and then after that you could do your calculation. So now this is the answer that I get. So of course this tells me that option C is the correct answer. You can practice the rest of the question until you fully understand or master the concept. Now the last question for this session is this one. First part it says of this question says, how many degrees equal to pi radian? Are they asking us to convert pi radian into degrees? Yes. Because how many degrees equal to pi radian? Now we've learned how to convert angle from one form to another, yes? So we're going to do that in both methods still. So pi radian multiply by, use a conversion factor, that is radian below, denominator, degrees up, right? Do you remember the numbers beside each? 360, and this is 2 pi. Radian cancels out with radian, pi with pi, 360 divided by 2, that is equal to 180 degrees, and that's it. See how easy it can be done? What if I want to use the other method, pi radian? We said every radian, it is equal to what? It is equal to 57.3. So just multiply by 57.3 degrees, you will get 180 degrees again, which is exactly the same as this one here. That is the first part of the question. What about the second part of the question? It says, this time, how many revolutions equal to pi radian? Are they asking us to convert pi radian to revs? Yes. Okay, so we're going to use the same procedure. So we'll say pi radian multiply by, use a conversion factor. Radian below, revs up, right? There is 1 here, there's 2 pi. So radian with radian, pi, and of course with pi, so that is going to be 1 over 2 rev. So you can write 1 over 2 rev, or you can write 0.5 rev. That depends on what is given in the option. These are both correct. What if I use the other method? Said pi radian. If I want to convert to rev, all you gotta do is just divide by 2 pi. So pi and pi cancels out. There's 1 left here, 1 over 2. And then, of course, 2 pi radian, of course, so that the radian cancel out. So it is going to be equal to just 1 over 2 revs, you could say, or 0.5 rev. That is exactly the same thing. Now, I hope you understood this very well. Make sure you practice more and more questions until you fully master the concepts, or you can convert any angle to any other form of angle that we've studied so far. Okay, now before I let you go, I would like to give you a quick recap or summary of what we've studied so far. We've talked about the types of motion. We said we're interested at this point in 2 types of motion, and they were translational motion and rotational motion. We said in translational motion, the objects change location like linear motion or in circular motion. While on rotational motion, the object, it is just rotating or spinning without changing their location. And remember the Ferris wheel. But we said also that whenever we have rotational motion, if we take the motion of any point on that rotating object, you will see that it is moving in a circular motion. So based on that, we can say circular motion is a special case in rotational motion. And then after that, we've defined both rotational motion and circular motion. We said rotational motion is the motion of an object, the motion of an object that spins. Remember the keyword? Rotation is spinning. And then for circular motion, the motion of an object that moves in a circular path. So circular motion, circular path, don't forget. And then after that, how we learned how we can measure the distance traveled, let's say by an object that is moving in a circle. We said we'll use the angle theta, or we'll measure the angle theta that is covered by the object, which is equal to the arc length divided by the radius. We also said that if the arc length is equal to the radius, then the angle that we get, it is 1 what? 1 radian. If that is the case, how can we define 1 radian? We'll say it is an angle. 1 radian, it is the angle, or you can say an angle, and we get it, or that is an angle whose arc length, it is equal to the radius, and that is approximately equal to 57.3 degrees, and also approximately equal to 0.16 revolutions. We said angles can be measured in 3 different ways. They can be measured in radian, in revolutions, or in degrees. Remember, 1 rev equal to 2 pi radian, and that is equal to 360 degrees. We can use that to convert the angles from one form to another. And then we also learned how we can do that in a faster way as well. That'll be the end for this session. Next time, inshallah, we will talk about the angular displacement, and that is also interesting. Till then, keep practicing. I'll see you soon, inshallah. Assalamu alaikum wa rahmatullah.